Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code P2122 indicates a low voltage issue in the APP sensor A, which is the throttle position sensor D in this context. The throttle position sensors are integral in providing feedback to the engine control unit about the position of the accelerator pedal. Located within the vehicle's accelerator pedal assembly, the APP sensor A sends voltage signals to the powertrain control module, PCM, about the pedal's position. The low voltage can lead to a myriad of performance issues, including acceleration delays or failure to respond to the accelerator pedal. Understanding this fault is crucial for maintaining the proper operation of the vehicle, particularly as it relates to throttle response in driving conditions. DTC P2122 pertains to an issue with the APP sensor A, also referred to as throttle position sensor D in diagnostics. This sensor is key in determining how far the accelerator pedal is pressed and subsequently informs the PCM about the desired engine power output. Positioned at the accelerator pedal assembly, it effectively gauges the driver's intention as to speed and power demands. When the voltage from this sensor falls below the acceptable threshold of 0.2 volts, the PCM flags a circuit fault. This low voltage reading indicates a potential problem in the APP sensor's wiring or the sensor itself, leading to inaccurate throttle response. Identifying the diagnosis path becomes essential to effectively resolve this low voltage error. Various factors can contribute to the appearance of DTC P2122. Firstly, poor electrical connections can disrupt the feedback signal sent from the APP sensor to the PCM. Loose terminals can also create intermittent connectivity issues, making it challenging for the sensor to relay accurate voltage levels. If there is a shorted APS1 wire between the PCM and the APP sensor, this can cause an incorrect voltage reading. Similarly, an open VCC4 wire, which provides power to the sensor, can lead to the same low voltage condition. Understanding these possible failures is crucial as it directs technicians towards specific areas that need further investigation. The symptoms associated with DTC P2122 can significantly affect vehicle drivability. One common symptom is delayed acceleration, where the vehicle may hesitate or take longer to respond when the accelerator pedal is pressed. This delay can be alarming for drivers, especially in situations requiring rapid acceleration. Additionally, an inconsistent throttle response may occur, where the engine fails to deliver the expected power based on pedal input. This can result in unpredictable vehicle behavior, particularly during merging or passing maneuvers. Furthermore, overall engine performance issues are likely, leading to reduced fuel efficiency and potential further damage to the engine. Recognition of these symptoms can prompt timely diagnostic actions. The first step in troubleshooting DTC P2122 involves verifying whether the problem persists. Start by turning the vehicle to the on mode, allowing systems to initialize without starting the engine. Utilizing the Honda Diagnostic System HDS, check the APP sensor A voltage. The threshold for this parameter should be 0.2 volts or less. If the readings meet this criterion, it's crucial to proceed to the next diagnostic step. Conversely, if the readings do not match the threshold, the system may not be at fault at this moment. Instead, focus should be directed toward inspecting for poor connections or loose terminals at both the APP sensor and the PCM. This detailed approach helps narrow down the potential sources of the issue. The second troubleshooting step starts with turning off the vehicle and placing it in the off-lock mode. This ensures safety while working on electrical components. Next, disconnect the APP sensor's 6P connector to isolate it from the circuit. After disconnecting, turn the vehicle back to the on mode to check the voltage between specified test points on the connector. This procedure is executed with particular attention to test point 1, which is the APP sensor's connector number 4, and test point 2 at number 5. If the voltage measures around 5.0 volts, this indicates that the power supply to the sensor is functioning correctly, allowing technicians to move to the next step in troubleshooting. Conversely, if the voltage is not as expected, further investigation into the circuit's integrity is warranted. In the third troubleshooting step, first, turn the vehicle off to ensure a safe testing environment. Next, use the HDS to jump the SCS, System Check Service line, and wait for more than 1 minute. Jumping the SCS helps reset diagnostic parameters to ensure accurate results. Then, disconnect the PCM connector A, 50P, to avoid any interference while testing continuity. The next crucial task is to check for continuity between the specified test points on the APP sensor connector, number 6, and the body ground. If continuity exists, this suggests a short in the APS1 wire running between the PCM and the APP sensor, which must be repaired. If continuity does not exist, further steps need to be taken to investigate further into the wiring integrity. For the fourth step, begin by connecting terminals A and B of the APP sensor 6P connector with a jumper wire to simulate continuity. This is done while the vehicle is still in the off lock mode and the APP sensor remains disconnected. The jumper wire from terminal A, number 6, to the body ground is essential to check for continuity between the PCM connector, A terminal number 32, and the body ground. Performing this continuity test helps identify any breakage or open circuits within the APS1 wire. If continuity is confirmed at this step, it suggests the wiring is intact. However, if there is no continuity, this indicates an open in the APS1 wire between the PCM connector and the APP sensor, necessitating repairs to restore connectivity. In the fifth troubleshooting step, start by removing the jumper wire previously connected to the APP sensor connector. Reconnect the PCM connector A, 50P, to ensure the electronic control module is linked back into the system. After securing the connections, connect terminals A and B with a jumper wire to facilitate an appropriate voltage check. Turn the vehicle to the on mode and utilize the HDS to check the APP sensor A voltage, as per the defined parameters. If the voltage remains at 0.2 volts or less, address any relevant service information linked to the DTC being troubleshot, or proceed to substitute with a known good PCM. Failing to meet the voltage criterion indicates that the accelerator pedal module requires replacement. This structured approach helps identify whether the issue pertains to the wiring or the component itself. In the final step of troubleshooting, the process begins by turning the vehicle to the off-lock mode. Using the HDS, jump the SCS line again, ensuring to wait for a minimum of 1 minute. This action serves to reset the circuit checks before further testing. Disconnect the PCM connector A, 50P, and then proceed to connect terminals A and B with a jumper wire, terminal A being the APP sensor connector number 4, to body ground. Then, you'll need to check for continuity between test points established by PCM connector number 45 and body ground. If continuity is present at this point, the VCC4 wire is in good condition. If continuity is absent, this signals an open circuit in the VCC4 wire that runs between the PCM and the APP sensor. Repairing this wire is essential to rectify the low voltage issue, contributing to DTC P2122. After performing the necessary repairs for DTC P2122, a final verification step is crucial to ensure that all issues have been conclusively addressed. Start by confirming that all repairs were executed correctly, including wiring repairs and any component replacements. The next important action is to clear any stored diagnostic trouble codes from the PCM using the HDS. By doing this, you ensure any previously logged codes do not trigger false readings. Following this, a test drive of the vehicle is essential to observe its performance under normal driving conditions. Monitoring how the vehicle responds during various driving situations will confirm whether the fix has resolved the issue. This thorough follow-up acts as a safeguard against future repeat faults. Preventive maintenance plays a vital role in reducing the risk of future DTC P2122 occurrences. One effective measure is the regular inspection of wiring associated with the APP sensor to detect any physical damage, wear, or corrosion that could lead to connectivity issues. Alongside, keeping an eye on the condition of all connectors helps ensure they remain secure and free from dirt or debris, as these factors can interrupt electrical signals. It is also essential to test the functionality of the APP sensor periodically, verifying that it operates within the designated voltage and signal output specs. Implementing these proactive steps will not only improve the longevity of the components, but also enhance overall vehicle performance. In conclusion, understanding the operation of the APP sensor A and its critical role in vehicle functionality is paramount when addressing DTC P2122. By following the detailed troubleshooting steps outlined, technicians can effectively identify and rectify faults contributing to low voltage readings. Each step methodically progresses through potential failure points, emphasizing thorough testing and repair for accurate diagnostics. Additionally, engaging in preventive maintenance practices can significantly decrease the likelihood of future DTC occurrences related to the APP sensor and ensure reliable vehicle performance. This multifaceted approach not only resolves immediate concerns, but also fosters long-term vehicle health and driver satisfaction. Please like and subscribe to the channel. See you next time.